study about the reactions of benzene and the kind of reaction that benzene undergoes. Now, benzene, although it contains pi bonds, it does not undergo addition reaction. It undergoes substitution reaction. Why? It should undergo addition due to the presence of these pi bonds, but still it is undergoing substitution reaction to maintain the aromaticity, to keep that aromaticity, to retain aromaticity. Clear? Now, what kind of substitution does this benzene undergo? It is electrophilic substitution, just like alkenes and alkynes. Due to the presence of these delocalized pi electrons, so this benzene is already an electron-rich species. So, a nucleophile, which is a negatively charged species, cannot go and substitute the benzene ring. So, this cannot take place. So, an electrophile, which is a positively charged species, it can be attacked by the benzene. So, benzene undergoes electrophilic substitution. Okay. In some cases, we will see that it undergoes a nucleophilic substitution, but it takes place at a very high temperature and pressure. So, now let's see what are the reactions that benzene undergo. The first reaction is halogenation. The first reaction of substitution reaction that benzene undergoes is halogenation, where benzene, in presence of halogen like chlorine, bromine and FeCl3, this is Lewis acid. This gives haloarenes. See. Clear? Now, how is this taking place? This is the Lewis acid. Lewis acid means it will accept an electron species or electrons. This FeCl3 triggers the formation of a nucleophile and an electrophile, Cl- and Cl+. Now, this is accepted by FeCl3 and this forms the adduct FeCl4- and benzene attacks this chloride ion Cl+. So, you see benzene is attacking this. This one, right? Now, it has lost its aromaticity. To retain its aromaticity, the bond of hydrogen will be cleaved. And this will again gain its aromaticity. So, chlorobenzene will be formed. This is your chlorobenzene. This is how the reaction takes place. Clear? And this H is accepted by the Cl- which is present in FeCl3. Thus, it will form HCl. So, this is how halogenation is taking place. So, bromination will also take place in the similar way. So, let's see. Now, for bromination, bromine will be required. The Lewis acid, FeBr3, or we can also add only Fe. If both will act as the Lewis acid, will give rise to bromobenzene and HBr. Same mechanism. This FeBr3, the Lewis acid, will trigger the formation of Br+, the electrophile. Now, this benzene will come and attack the Br+. So, this will again form an intermediate like this, where the benzene will lose its aromaticity. Clear? and there is a positive charge. So to gain aromaticity, hydrogen will be liberated, and this will be eliminated with the help of this adduct, that is formed. So this will lead to the cleavage of this C and H bond. Hence, we will get back out the aromatic benzene ring, and the halobenzene will be formed, or bromobenzene will be formed. Now, in case of iodination, we cannot directly add iodine, because same way, if I add iodine, it is a reversible reaction, first thing, and this will lead to the formation of iodobenzene. At the same time, HI will be formed, but HI will again get back to this. So it will reduce this again to iodine. So we have to oxidize this thing. That's why we add nitric acid, iodic acid. So this, as soon as this is formed, this oxidizes HI, like concentrated nitric acid is a strong oxidizing agent, oxidizes HI and gives rise to H2O and iodine. Okay? So this is your halogenation reaction for benzene. Next reaction is your alkylation, or acylation reaction, where a carbon atom is attached to the nucleus of the benzene, and this reaction is known as Friedel-Crafts reaction, and this is one of the method by which we can add a carbon atom to benzene. Like this was the way how halogen was attached to a benzene ring. So Friedel-Crafts reaction will help you to add a carbon atom to the benzene ring. So let's see. So the next one is alkylation or acylation, and this is an end reaction. This is Friedel-Crafts alkylation or acylation. So what happens? Benzene, in presence of an alkyl halide, same, a Lewis acid is required, anhydrous, LCl3 is required, and this forms toluene. This is alkylation. If this would have been the ethyl group, ethyl benzene. How is this occurring? Same way, this LCl3 is triggering the formation of the electrophile, LCl4 minus CH3 plus. Now the benzene will come and attack this carbocation, the electrophile. And in case of acylation, benzene in presence of acetyl chloride anhydrous LCl3, this Cl is leaving, LCl4 is formed, Cl4 minus is formed, and it gives rise to the electrophile, this. So the benzene attacks this C. Thus, what is formed? It forms a ketone. This is acetophenol. This is called acetophenol. For the formation of benzophenone, we take benzene and we take benzoyl chloride. This is called benzoyl chloride. In presence of anhydrous LCl3, this will give rise to benzophenone. So this is your alkylation. So this is a process where I can add one carbon atom attached to the benzene ring. So from here, from benzene, I can form benzoic acid, because if I oxidize toluene in presence of alkaline KMnO4, this gets oxidized and forms benzoic acid. Clear? So any compound containing C, so first thing that we have to do is to add a carbon atom to the benzene ring. From there we will get the solution. Next is nitration of benzene. So we will add a nitro group to the benzene using concentrated nitric acid and sulfuric acid, where NO2 plus is the electrophile. In this case, the electrophile was the this one methyl carbocation, and this one was the acetyl carbocation. And remember one thing, this C is attached to the benzene ring, not this C. There is a confusion that many people think that this carbon is attached to the benzene ring. No, this carbon, the carbonyl carbon, which is attached to the halogen atom, that carbon will attach to the benzene ring, because that particular carbon will form the carbocation. That will be the electrophile. Clear? So next is nitration. Next is nitration. So benzene in presence of nitric acid, which is concentrated, as well as concentrated sulfuric acid, we will get nitrobenzene. And the electrophile that is generated is NO2 plus. So if I make a list of electrophile that is generated for halogenation, the electrophile was X plus, number 1. Number 2, for alkylation, the electrophile was R plus. If it is methyl, C plus. For acylation, it is R, C double bond O plus. So this carbon will be attached. For nitration, it is NO2 plus. How is this formed? If I write nitric acid in this way, add sulfuric acid, this will generate the NO2 plus. The same time, 3O plus and 1 HSO4 minus. So this is that electrophile. So this will be attacked by the benzene ring and it will form nitrobenzene. Now when this is formed, this is a very important intermediate, because if I convert this to aniline, so I am converting nitrobenzene to aniline using reducing agent like tin HCl, I get aniline. Now if I convert this to diazonium chloride N2Cl minus in presence of NaNO2 plus HCl 0 to 5 degrees Celsius. Now when this diazonium chloride is formed, this gives rise to many products. So I can also get benzene again from diazonium chloride by adding hypophosphorus acid, hypophosphoric acid, and heat it in presence of water. I will get back benzene again. I can also get phenol by adding water to this. I can get cyanide. I can get anything I want. Okay? So this is a very versatile, we can say an intermediate or any substance or a product that is formed from the nitrobenzene. So preparation of nitrobenzene is very important, because once nitrobenzene is formed, I can reduce that to aniline, and from there diazonium chloride I can get any benzene derivative from it. This is nitration. Next is sulfonation. Number 4 is sulfonation. That means addition of sulfonic group. Benzene plus sulfuric acid will give you benzyl sulfonic acid. The electrophile in this case is SO3. How is this formed? SO2H. So if I write like this, in presence of water, if there is, then it will give rise to SO3, H3O plus, HSO4 minus. Okay? So 3 will be 3. So in this case, for sulfonation, the electrophile is SO3. So this is very important. Okay, so these are the few reactions on benzene, and these are mostly useful for the conversions and for the identification of the unknown product or the reactant. So that's all your benzene. So in the next lecture, I will discuss few problems of the conversions and identification of certain compounds on these hydrocarbons, aliphatic as well as both aromatic. Thank you.